Today on the syllabus it says we're going to be talking about confounding and extraneous variables, but we kind of already covered that last time, and it's well covered in your textbook, I think, in a very clear way. So what I want to do today is have everybody get a jump start on the monstrous problem set that is problem set number 1. So here's what we're going to do. We're going to start, and we're going to start trying to answer the questions one by one, see how you do. So break out all your notes. You want to have everything out, because you're going to be looking stuff up. We're going to try and see how many of the answers we can generate in class so you have less homework to do over the weekend. Huh? Is that bad?
No.
Oh, yay! Less homework over the weekend! That's supposed to be a good thing. Not like, oh, but I wanted to do it all on my own. Well, okay, if you don't want any help, feel free to leave. You know, if you don't, if you like want to just go for it on your own. But we're still, we're going to work through it. I just want to see. This is a very long problem set, and I want to see how you do. So you can break out your notes, and we'll talk about answers. See if we agree on why certain answers are what they are. Now you don't have to have a copy of this printed out or anything right now. I'm going to project everything up here on the screen, so you can just keep track. We're going to start right at the beginning. So this is problem number 1. And problem number 1, they pretty much go in order in terms of how we've covered material in the class. So first thing we want to talk about is different ways of knowing. What were the ways of knowing we talked about? Intuition, tenacity, authority, rational discourse, empiricism. Okay, so you guys remember those. All right, if you remember, if those sound familiar, you're in good shape because those are going to be on the test. So, we take a look at the first example. Ellison goes to the doctor because a wound in his arm is not healing as fast as he thinks it should. The doctor tells him he has an infection and he needs to take a specific type of antibiotics to treat it. Ellison heads straight to the drugstore to fill his prescription. What way of knowing is being characterized in this example? Authority, okay? And why do you think that's the right answer? What is it about that says authority to you?
Well, he went to a physician, and the physician told him, this is what's wrong with you, and this is what you need to do. So he went to the drugstore.
And he just followed up on it. So basically he took what the physician said as true and acted as if it were true and behaved appropriately. Right.
He's an expert, so...
That's right.
Really
And authorities, he went to med school, so obviously, you know, he knows he's a relevant authority too, right? I mean, if he came to me and said, why won't my arm heal? I'd be like, wrong kind of doctor. Yeah. Now, if you want to talk about visual word recognition and non-alphabetic orthographies, I'm your person. But probably not. Okay. So, authority. I'll go with authority on that one. And here's a little tip. And this is really good for exams as well as working on problem sets. Make sure you read the instructions and answer all the parts. Because sometimes on tests, students will answer part of the question, but not the whole question, and they lose some points. Because they answered the first part, which is what they thought I was going to ask them. And they ignore the second part because maybe that's something new. Right? Maybe I'm asking them to think about it in a little bit different way to see if they can make a leap about the concept. So make sure you always read the question, read specifically what I want you to do, and if you're stuck during a test, something's not clear, then I will always be here during exams, so you can always come up and ask me for clarification. Okay, don't ever let being stuck on a question keep you just sit there spinning your wheels, because in some cases, you'll run out of time if you do that. So if you realize you're stuck, go over it, come back, or come up and ask me, and if I can give you a hint, I'll give you a hint. Okay, to help you get unstuck. But sometimes students go, I don't know what that word means. What does it mean? I'll be like, oh, sorry, that was vocabulary. You kind of need to know that one. I can't help you there. But if it's just that I've worded the question in a challenging way or something like that, just come ask and I'll try to clarify for you. Okay, next one. A Formula One driver is coming up on a hairpin turn where he would normally accelerate. However, something tells him there's a problem, so he brakes sharply instead, thereby avoiding a pileup of cars that was just around the corner. True story. Yes? Intuition. Why do you think intuition? Yes?
It says there's something tells him that there is a problem, so that's a gut feeling.
It's a gut feeling, right? Intuition is about gut feeling. You don't really know why you think it, you just think it. So when you have a statement where if someone thinks something is true, but they can't tell you why they think it's true, probably the gut feeling, that intuition part. All right? Write stuff down. You got this? All right. All right. While having lunch at a local restaurant, Angela and her friends decide to spend some time at the pool. Angela insists they should wait for at least an hour before getting in the water because she believes swimming too soon after eating will result in stomach cramps. She continues to insist on the importance of waiting, even after one of her friends whips out her cell phone and shows her online a news story about how scientists have demonstrated that waiting to swim after eating is unnecessary. We gotta hit the pool, we gotta work on our tan, let's go. And she refuses to change her mind. Tenacity. Okay? So, what about this tells you it's tenacity? What is tenacity? Where do you see it here? Can be stubbornness. Okay, what's another? That's kind of a negative spin on tenacity. What's a positive spin on tenacity? It's conviction, right? It's strength of conviction. So one person's stubbornness is another person's strength of conviction, right? People say you're stubborn. You say I'm not stubborn. I just have strong beliefs. Right? Same thing. It just depends on how you spin it, right? Okay. So, but she believes this so strongly that even in the face of counter evidence, she says, well, I don't believe that evidence, or I don't think that evidence is enough to change my mind. Maybe more evidence would, but that by itself, I just did a search on Google and it says it's okay, is not enough for me to go get in the pool. Okay. The members of Dr. Grant's lab group are trying to decide on a good operational definition of memory to use for their next study. After much discussion, they decided to measure the number of words from a specific list that participants could remember after 1 minute of concentrated study. Okay, we've got to vote for empiricism, we've got to vote for rational discourse. You think it's rational discourse? You change your vote?
We convinced him.
You convinced him. He was persuaded. You didn't have strength of conviction. No, okay. He was not being tenacious in his choice. All right, that's good. Okay, so explain what about this says rational discourse to you.
There's a hint there, Dr. Grant's lab group, and under the...
There's always hints.
There's always
It's not, there's always going to be hints. The question is, where are the hints? Right? Okay, so you say there's a lab group, okay?
So under the rational discourse, there's a group thing. Some smart people gather up and they decide what's the truth.
They make a decision. What's a planet? Is Pluto a planet or not? No. Different smart groups of people decided it was. A new smart group of people decided it wasn't. Same idea here. So operational definitions are typically determined by rational discourse. People get together and say, what would be a reasonable way to define this for the purposes of our experiment that we're conducting? So we agree. It may also happen as a form of authority. Somebody who's done a lot of research in that area might say, well, here's a definition that I've always used and it's worked really well, so that's the one we're going to use. And all of a sudden it becomes authority making the decision. While jogging around Grant Park, Maggie says to her friend Paola, there are way more dogs than cats in this neighborhood. I mean, everywhere you look, there are dogs running around the park, but you never see any cats. It's empiricism. What's she basing her decision on?
Observation.
Her observation, right? What she's actually seeing. So she's, whether that's what she believes is true based on her personal, actual physical observation. She's like, look, everywhere you look, there are dogs running around the park. I'm just like, well, cats, they're like exercise, whatever. That's for dogs. I'm not doing that. But, she says, here, look at what's true based on my sensory experience. So that's how we know that's empiricism. Okay, so these are the kinds of examples that examples of how I might ask you a question on a test. So I don't just give you a straight out definition, I'm going to give you a real world example and you're going to have to be able to figure out what concept is represented by that example. Okay? All right. Let's talk about these terms now. So this question says, explain each of the phenomena below in your own words and how it might negatively affect the value of a piece of information. Okay, so we want to make sure first that we know what each of these terms means. And then we want to think about how it might, because, I mean, these are all good things sometimes, but sometimes they're not good things. So, I mean, sometimes they work in our favor, sometimes they don't work in our favor. So, let's think about each one of these terms and how it can negatively affect us as a researcher. So who wants to go first? Availability heuristic. I have to choose between my front row. Yes, I'm going to pick somebody over here just for fun. I know I always hated that. It's like, pick me. But I want to give everybody a chance. Yes?
So the availability heuristic is basically like choosing people to do your experiment by location who are close to you, the ones who are like nearby, so you're choosing them. So it could be negatively affect the value of a piece of information by giving you like a biased result because you're not getting all of your like.
Okay. So the availability heuristic has to do with using the information that's immediately available to you, right? So you could think of that as, you know, you take, if I ask you a question, like I say, which do you think is more dangerous? Driving down the connector at rush hour or flying in an airplane? And in your head you think, well, all day, every day I hear about accidents on the connector, and I haven't heard of a plane accident anytime recently, so I'm going to say driving on the connector is more dangerous. The idea is whatever comes to mind easily is probably the right answer. You're treating it like, because it came to mind easily, that's probably the truth. You're trusting your kind of the first answer that comes to mind, and the reason it's coming to mind is because it's a high probability answer. You've heard it a lot or you've had a lot of experience with that, so you think, well, that's probably the most common thing. Okay? But you're right. Sometimes when you take the most common or easily accessible answer, that's not the right answer, right? The most easily accessible answer may just be the one that's consistent with your personal experience, but not consistent with reality. Maybe you have a biased sample, right? Maybe you've had certain experiences that have been exaggerated or reduced relative to other people's experiences. You know, if you happen to live in a really violent neighborhood, you might think that violence is common everywhere when it's not. Or if you happen to live, more critically, if you happen to live in a very peaceful, protected neighborhood, it may be really hard for you to understand why people are afraid of the neighborhood they live in when they live somewhere that's very violent, because you just can't imagine a world like that, right? You pick the answer that's most easily available to you, and as a result, you might miss a truly representative answer. But I really like your example. That was good. Okay. So what about belief perseverance? What does that mean? Yes.
This is similar to tenacity, where you believe something strong enough that it's kind of like you're forcing that to be the outcome of what you're looking at.
Okay, so belief perseverance can be a downside of tenacity, right? When you're so convinced that you're right, that even in the face of overwhelming counter evidence, or maybe not even overwhelming, but very persuasive evidence, you refuse to change your mind. Right? You're just like, I don't care what you say, I don't care what you do, I don't care. My strength of conviction is so powerful that I shall not be persuaded from my course of action. Basically, teenagers. Okay. They get, well, you know, I have a 14 going on 25-year-old, and sometimes she has belief perseverance. She's pretty sure. I remember when I was about 16, and I was very confident that I understood how the world worked, and my parents, I mean, what did they know? They did not understand how the world worked. They just were completely clueless. It's sad how kind of from the time 16 down to now 46, I seem to be getting less informed. I realize more and more what I don't know. When you're 16, you know everything. You have great belief perseverance then. Great confidence, strength of conviction in your own interpretation of the world. Okay, so how can belief perseverance cause you trouble as a researcher?
You're blind to evidence, or like I said, if there's something that's overwhelming evidence, you just won't accept it, or you'll just like look at you'll ignore outliers, and just look at like, oh no, this is right, or like what was that one term?
Confirmation bias.
Yeah.
Look for example that you're right. I heard there's a news story on NPR, sorry. Talking about NPR. There was a news story on NPR this morning, and it was about how and it was about bilingualism and research on bilingualism. And they were saying how it's really interesting that the research on bilingualism that tends to get published is research that shows that bilingualism has cognitive advantages. And the research that doesn't tend to get published is the research that shows bilingualism doesn't result in cognitive advantages. And they said even though the research might be comparably well performed, the stuff that shows a significant difference between bilinguals and monolinguals on different cognitive tasks is way more likely to get published. And I realized that I'm a psycholinguist, right? I study language, and multilingualism is one of the things I'm interested in. And as I was listening to the story, I'm like, well, that's probably because those studies that show bilingualism isn't an advantage are wrong. And then I was like, oh my God, look at me, scientist, being like, believe perseverance. Like, I don't want to hear that these studies are, not, the studies that I know about are not representative, right? Because I'm thinking availability heuristic. I've read so many studies that say that's true, but that's an artificially inflated proportion because apparently studies aren't getting published that show a balanced view. In fact, there may be even more studies showing no significant difference, and editors are arguing, well, there's no difference, so it's probably they did something wrong in their study. I mean, again, engaging in belief, because a null result, it's possible that you just didn't test what you needed to test, right? You could have, you might have missed something that's really there, type 2 error, right? They seem to be much more likely to attribute that null finding to type 2 error when it is inconsistent with their own beliefs that in fact bilingualism does have just this full range of cognitive advantages. And I found myself actually doing this because we do, when someone challenges a belief that we hold, and we're like, I stand up here in front of my psycholanguage class and I teach that, right? I have a whole lecture on bilingualism and the cognitive advantages of multilingualism, and here's all the research, and I'm like, oh man, I'm going to have to go back and change that whole lecture now. And bring in all this other evidence and say, all right, critical thinking students, here's what the evidence says, so now we have to be more cautious in the kinds of claims that we're making. But, it even happens to me. Why? Because sometimes professors are overconfident. Yeah, see, even I fall prey to that. So what is overconfidence? Yes?
Is it when you tend to just believe on your own judgment?
Yeah. And when you believe you know enough, what do? I know enough to make a decision. Yeah.
Do you not back it up enough?
You might not back it up enough, or you might not look for other help, right? You might go ahead and move on even if you're not really ready to do what it is you think you're ready to do. But you're like, I have all the information I need. There might be other information, but it's not as good as the information I have. Right? Or I trust my own judgment. I'm a smart person. And I believe this is true, therefore it probably is. Right? Overconfidence. So when you're overconfident, when you put more weight in your own beliefs than you probably should, in your own value as a decision maker than you probably should, and you put more value on the facts you already know compared to the facts you maybe don't know yet, all of those things can negatively impact you as a researcher because, again, you're not looking at all the data. You're cherry picking, and we don't want to cherry pick. If we are going to be good scientists, effective scientists, we have to take into consideration a broad range of data and make sure that it's consistent with the ideas that we're putting forward. Okay. What about selective observation? What's that about? Yeah.
Really just looking for what goes with your setting.
With my setting?
Setting.
Oh, my setting. Like, with my setting. My setting is weird. So I'm going to, no, okay. So what goes with your study? So selective observation is when you pay attention to evidence that is consistent with the way you think things work. And I mean, this is another fancy word for cherry picking, right? You give credence to evidence that is consistent with your way of thinking, and you may just completely ignore evidence that is inconsistent with your way of thinking. So you selectively observe. You say, well, I'm being empirical. I'm out here observing the world. I'm taking in real life examples. I'm not just arbitrarily making this up. But if you are selectively observing and not representatively observing, then your data is skewed, and you're going to fall prey to things like availability heuristic, right? Mm-hmm.
Maybe a type 1 error that can come in that too?
Sure, type 1 or type 2 error, depending on whether you are missing something that's really there or finding something that isn't really there.
Yeah, type 1 is the false positive.
Yeah, type 1 is a false alarm, and type 2 is a miss. So you could actually miss something that's really there, or you could think something's happening that's not really happening. Yeah. Selective observation can hurt you both ways, because it depends on, if you come in believing something's true and you only focus your efforts on on identifying examples of that. So it's very closely related to confirmation bias. These two go hand in hand. When you have confirmation bias, when you're doing that, then you are going to be selectively observing. So we can use these terms fairly interchangeably. Okay. So as you can see, all of these issues with threats to good, clear ways of thinking have to do with bias, right? Not really taking in representative evidence, but kind of cherry picking, blocking out cases that don't support your belief. Scientists can't really do that to the extent that other people get to do that, because people might make medical decisions, they might make social decisions, they might make law, policy, all kinds of things based on the evidence we put forward. And if we put forward biased reports, we can get bad results for people. Okay? All right, the following headlines, these are real headlines. For each one, identify the type of claim. Is it a frequency claim, an association claim, or a causal claim? And see if you can figure out what the variables are that are involved. And if you can, explain what it was about the headline that guided you to your decision. So the first headline is, OMG! Texting and IMing doesn't affect spelling. Yes? Okay, why do you think it's an association claim?
Because of the word
Texting and IMing doesn't affect spelling. So they're just saying that a lot of people are concerned that because when people text and they IM, they use abbreviations, that's going to make people's spelling worse, right? Now let's think about that word. Make people's spelling worse. When you make something happen, what kind of claim is that? A causal claim, right? So the idea is that it doesn't affect spelling. It doesn't do anything to the spelling. That's effect is a kind of automatic result word. So words that suggest there's an actual big change, like affect or curb or cause or make, those verbs. And there's a really nice chart in your textbook that has verbs associated with causal claims and verbs associated with association claims. And those verbs are good to know. They might be handy verbs to either commit to memory or to put on your note card, because don't forget, for the exam, you get one 4x6 note card with handwritten notes on both sides. So little reminders like that can be very helpful. Help you identify claims. So, oh my God, texting and IMing doesn't affect spelling. Good Jade. That's really good to know. Although what's really weird is when my 81-year-old mom texts me using text spelling. It's like, this is the woman who taught me I better be able to spell anything perfectly every time, and then she's like, you are so great, with an 8, and I'm just like, Mom, it's really weird, okay? Just spell stuff. I'm not ready for my 81-year-old mom to use text stuff. It just freaks me out. Mom, don't spell great, G-R-8. Just don't do it. Okay. Oh, it's nice that she still thinks I'm great. Okay. So what about, so it's this verb here, affect, that should be giving you some tips. Now what are the variables here? When we talk about a causal claim, we're talking about an independent variable and a dependent variable. So can anybody identify what independent variable we might be talking about and what dependent variable we might be talking about? Yeah.
Independent would be have one person only text and spell words, and have another person only like abbreviate, and then have them do like a spelling contest, or a bunch of people do that.
Okay, so we're going to be measuring how many errors they make in spelling, right, when they write normally. So that's going to be what we're measuring. So your ability to spell correctly is the dependent variable, right? That's your ability. That's the thing that's going to be compared across the groups. And the groups that are going to be compared are people who I am, or text, or don't, right? And the expectation is that if this claim is correct, that the people who I am and text, and when they do that, they use abbreviated spelling, aren't any worse at spelling normally than people who never use that kind of abbreviated text. So there's no difference. So the IV would be whether you use abbreviated spelling or not, and the DV would be how many errors you make in regular spelling when you have to do that. Okay. Bipolar disorder tied to mother's flu in pregnancy. Tied to, right? Tied to. That's another way of saying it's connected, it's associated, it's linked. These are all verbs that suggest it's correlated. Predicts. These are things that go with association claims. So association claims are between dependent variables. So we can also sometimes see them with an independent variable and a dependent variable if you have a quasi-experimental claim. So what do we think is happening here? What variables are happening here? What are we measuring? Okay, so mothers who get the flu when they're pregnant and mothers who don't get the flu when they're pregnant. Okay, and what are we comparing about them? The likelihood of who getting bipolar disorder, do you think?
The child.
Probably the baby's likelihood of developing bipolar disorder. So they're looking at like maybe how severe the mother's flu was during pregnancy. If she had the flu, it could be everywhere from no flu to a very severe flu, and then looking to see the relationship between that and the likelihood that the baby develops bipolar disorder. But again, this is not causal. Okay, they're not saying if the mom gets the flu, then the baby will develop bipolar disorder. That's not what they're saying. It's not an if-then causal statement. It's that there's a connection between bipolar disorder in children and the likelihood that their mother developed a particular type of illness or had an illness to a certain degree while she was pregnant. So there's a connection. It's not always going to work out this way, but it seems to increase the risk or increase the likelihood. What about some diagnosed with PTSD return to war? Yeah. Sounds like a frequency claim to me. I think you're right. So frequency claims measure just a single dependent variable. We talk about things like rates, proportions, percentages, and something like some, that's basically just talking about a proportion, probably a minority proportion. some diagnosed with PTSD return to war. So even some members of the military, even once they've been diagnosed with post-traumatic stress disorder, still go back into the battle, right? Even though that's going to be a really dangerous and frustrating situation for them if there are a lot of triggers in that environment. They still do it because that's their job. So what are we measuring? All we're looking at here is the proportion of people with PTSD who return to a war zone. Right? People who've been in a war zone, develop PTSD, and return to the war zone. So the dependent variable is that proportion. Oh, look, this one looks familiar. You guys should recognize this from last time. Right, Dr. Webb? Now, I noticed, I want to go over this again, because as I was looking at everybody's note cards, I saw that there was some confusion about the answer, and I want to double check and make sure everybody's really clear on what the answer is. So this one says, Dr. Webb conducts a research study investigating the effects of a new drug that's intended to reduce the craving for alcohol. A group of alcoholics who are being treated at a clinic is selected for the study. A third of the participants are given the drug along with their regular treatment. Another third receive a placebo in addition to the regular treatment. The remaining third receive only the regular treatment. Dr. Webb records whether each individual is still sober after 6 months. Okay, now, when I asked you guys what is the independent variable in this study, a lot of people on their note cards wrote the drug, okay, or the drug treatment. And that is not the independent variable. Why not? Why is the drug not the independent variable? Yes? Hmm?
That's the thing that's
Okay, well,
It's not consistent
no.
in every treatment.
Not every treatment involves a drug. So you can't say the drug is the treatment. You can't say the drug is the IV. Okay? The independent variable has to be something that has all of the conditions in it. Right? So you can't say that the IV is the drug because there's only one condition in here that has a drug as part of the treatment. So your independent variable has to include all of the groups. So your independent variable has to be something like the type of treatment offered. And it manifests in 3 different ways. They either get the drug plus regular treatment, a placebo plus regular treatment, or just the regular treatment, which is probably a therapy, talk therapy of some kind. Okay. So your independent variable has to include all of the cases. It can't just be one. So while it's true, and I understand the thinking here, they're thinking, well, the independent variable is what's being manipulated. What are they manipulating here? The drug. Well, kind of. That's one of the manipulations. But they're also manipulating other things, and your independent variable has to include all of them. So it needs to be general enough to reflect all of the treatments. So that, because what you should recognize is that the drug plus regular treatment condition is the experimental condition, right? That's the experimental group. And there are other conditions in the study, and all 3 of those treatment conditions are manifestations of that independent variable. So the best answer for what is the independent variable here is something more general like the type of treatment offered. But if you just say the drug treatment, you're not capturing what's happening in all 3 of the conditions because at least 2 of the conditions aren't actually getting a drug. Does that make sense? Does anybody have any questions about that? But it's clearly manipulated, and it's manipulated because, we talked about this last time, because it's possible to randomly assign the participants to one of the 3 conditions. It's not a subject variable. People don't inherently have drug treatment. We have to give it to them. And so we have IV of type of treatment offered, and it's a manipulated variable. So that's this first one. The levels of the IV. Okay, so what are the levels of type of treatment? Drug plus regular treatment, placebo plus regular treatment, and just regular treatment. Okay, so those are our levels. What kinds of controls are being used here? There's two. Placebo control, which is the one where they're getting placebo plus regular treatment, and regular treatment control, or standard treatment control. Right? Because here you've got people who are at a clinic because they're sick. It's unethical for us to deny them treatment. So we have to do that standard treatment control. So we've got a standard treatment control plus a placebo control. So no one is being denied treatment at all. But we are able to see whether the standard treatment is equivalent or worse or better than standard treatment plus a placebo or standard treatment plus the new drug.
So the type would just be control.
There's two types of control groups. One is a placebo control group, and the other is a standard treatment control group. There's two types of controls being used in this case. It's possible to have multiple controls in a single experiment because you want to compare different aspects of the design. Okay. And we decided that this was between subjects or within subjects? Between. Because why?
Different groups receiving different treatments.
Different groups receiving the different treatments. Okay, so a different group of people are getting the drug plus regular treatment, then are getting the placebo plus regular treatment, then are getting just the regular treatment. So 3 different groups of subjects, so this is a between subjects design. Okay. Is this a true experiment or a quasi-experiment? What do you think? Okay, quasi-experiment. What are the requirements for a quasi-experiment?
They come with something that you're testing, you don't make them an alcoholic.
Well, that's true, but that's just a characteristic of the participants. But is it related to the independent variable? Well, it's why they're in the study, but it's also a constant. Everybody in the study is an alcoholic. It's a constant, it's not a variable. And whether something is a true experiment or a quasi-experiment has to do with the characteristics of the independent variable. What has to be true about the independent variable for something to be quasi-experimental? The independent variable has to be a subject variable. So for example, if I were doing an experiment where I were comparing male alcoholics to female alcoholics and their response to a particular treatment, that IV, so maybe I want to do the drug plus standard treatment for both of those groups. So now my IV is the sex of the patient. That's a subject variable, and that would be quasi-experimental. But in this particular case, the independent variable is type of treatment being offered. It's a manipulated variable. I can randomly assign subjects to the different conditions, and so we have a true experiment. So the connection to make here is that to get a true experiment, you need an IV that's manipulated. If you have an IV that's a subject variable, like you were thinking of, you were making the right connection, we just got to make sure we map it onto the independent variable. If you have an IV that's a subject variable, something that reflects an inherent characteristic or pre-existing state of the subjects in the study, and that's what's defining the groups in your independent variable, then you have a quasi-experiment. Okay, so if I were comparing patients who were between 18 and 28 to patients who were between 29 and 38 to patients who were between 39 and 48, that would be a subject variable because their age is something they come in with. I can't randomly assign you to how old you are. That would be a quasi-experimental comparison. Does that make sense?
Just to go off of that, so essentially a quasi-experiment can not be randomly assigned, but the
That's right.
other one can.
Yes, that's exactly right. So if you can randomly assign subjects to the conditions of your IV, you have a manipulated variable, and that means you have a true experiment. But you have to be able to do that randomizing procedure, either random assignment or randomization of the orders of presentation through counterbalancing in order for it to be a true experiment. If you can't randomize, then you've got a problem. At least it's not a true experiment. So you can no longer make a causal claim. The dependent variable in the study is what? Let's go back and take a look at the description. What's the dependent variable? What is being measured?
Sobriety.
Sobriety, right? The proportion of subjects who are sober after 6 months. And just, fun fact, since we're comparing 3 groups and we're looking at proportions with which the proportions in each group, the kind of statistical analysis you would do for this, chi-square. Just a, you guys did chi-square in 3510? This is the chi-square kind of problem, where you're looking to see if the proportions are different from one another for the 3 groups. You might predict going in that the proportions will all be exactly the same, that there will be no difference between the proportion of students, proportion of subjects in each group who are still sober after 6 months, and you look to see if the proportions are different from that expectation. So a chi-square, particularly a test for goodness of fit, would be the right test to do for this kind of study, because you're looking at proportions for your dependent variable. All right. Ooh, now we're going to get tricky. Describe circumstances under which the participant's age would be an extraneous or nuisance variable, but not a confounding variable in the study. Ooh. Now I'm getting tough. It is. Okay, so let's make sure we're clear on the difference between an extraneous variable and a confounding variable. Okay, you have to make sure you know the difference between these two things. An extraneous variable, or a nuisance variable, is just any variable that we're not controlling. Any variable that we're not controlling. So if I have people in the study who are all different ages, we're talking about people who are alcoholics. Some people develop alcoholism very young, right? They start drinking when they're 15 or 16 years old, and they get hooked. Some people start drinking later in life, right? So people who can develop alcoholism at any point. So if I have people of all different ages in my study, it's not super restricted, right? I mean, I don't expect that like everybody, it's not going to be a constant. Not everybody in my study is going to be 25, right? Or even restricted, like between 24 and 25. There's going to be, if people in my study represent all different ages, then it's an extraneous variable if I don't control it. Okay? Now, it's potentially a nuisance variable. It could potentially be a problem if I have a disproportionate number of one age group or another in the study. But it's still not clear that people who are older alcoholics are necessarily different from people who are younger alcoholics. Although, if someone's been an alcoholic for 30 or 40 years, that's a really different thing than having been an alcoholic for a year, right? And how you might respond to treatment could be an issue. So how old you are and when you started drinking in an addicted way could really be relevant, right? So older people are more likely to have been alcoholics longer, and that could affect how they respond to treatment. Does that make sense? So that's an extraneous variable, and it's something you want to think about because it could influence how they respond to the levels of your IV, right? If you imagine now, okay, imagine that it just so happens, say you do random assignment, and say you have a relatively small group of people in the clinic to work with, you do random assignment, and just by chance it turns out that The youngest alcoholics are disproportionately in the regular treatment group. The middle-aged alcoholics are disproportionately in the placebo group. And the oldest alcoholics are disproportionately in the drug treatment group. Now, you've got a confound. And that's because age is overlapping with the levels of the IV. So now, say you find, for example, that under those circumstances, the drug treatment doesn't seem to be doing much compared to the regular treatment by itself. Well, is that because the drug is ineffective? Or is that because you have a disproportionate number of older alcoholics in that group? They've been alcoholics the longest and they're most resistant to changing their behavior. You can't tell which is which. So if age varies a lot among your population, what do you want to do? You either want to hold it constant if you can, or balance it across conditions. And it's going to be really hard for you to hold age constant. You can't say, okay, everybody in the study has to be 25. There's going to be a lot of people that will be out of the study that need help. And it doesn't really make sense to just pick an arbitrary age like 25. So instead what you might want to do is either a matching or a restriction procedure where you say, all right, we're going to restrict our study to people who have only been alcoholics for at least 5 years, or people who have only been alcoholics for 10 years, or people who are, so you don't want to do something to manage, to restrict it so that you don't have so much variation. Or you might say you have to be between the ages of 25 and 45 to participate in our study. You could do that kind of restriction. Or you could say, you know what, let's match them. How would we match them? Say you have a bunch of patients, all different ages, what would we do? How do we match?
You have to put the ages in some kind of order, like
Okay.
ascending or descending.
Okay.
And then set up blocks for each of your treatment, like A, B, C, and BAC, etc. And then take the person, whoever's at the top of your list, and just start assigning them into your blocks.
Okay. So we could do a matching procedure where we put everybody in the study in order by age, and then we take the top 3 oldest people, and then we randomly assign them, 1 to each condition. We take the next 3 oldest people, and we randomly assign 1 to each condition. And if we did that, then we would be balancing age across the conditions. It's extraneous, but now it's no longer a confound. So the difference between an extraneous variable and a confound is that extraneous variables are not specifically being controlled. They're not our IV, they're not our DV. They're not something that we're intentionally trying to control or measure. They're a thing that we can either convert into a constant, hold it constant, or we can try to balance it across the conditions or manage it through range restriction matching. That's an extraneous variable. A confound is a variable that is overlapping. It's systematically overlapping with our independent variable and making it hard for us to tell whether it's a specific treatment or that extraneous variable that's causing the change. Does that make sense? So confounds are deadly. Confounds make it virtually impossible for us to effectively interpret our data. Extraneous variables make our data noisier and harder to interpret. Confounds mean we literally can't interpret our data and know whether we're right or not. All right. So that's actually F and G. Well, we're whipping through this. You guys are going to have very little to do this weekend. Just type up answers. Send it. Does everybody feel like these concepts we're talking about seem familiar? You're like, okay, I get that. We talked about that. You're not throwing out anything here that I have no clue about.
So you're solidifying.
Is it coming together, or does it feel like, and are you feeling that you're like, okay, I have the information I need to answer these questions? If not, make sure you let me know, because this is the point where you want me to clarify, not after you take the test. Right? You want to tell me now that you think you need more information, not afterwards. Okay. Do you have a question? Question? We're good? No, we're good? Okay. All right. It says, a memory researcher wishes to compare long-term memory for 6 different word lists. In other words, list A, list B, list C, list D, list E, and list F, using a repeated measures design. Repeated measures is another way of saying what? Within subjects, right? So this is a within subjects design. Okay, so the same subjects are going to experience all of these conditions. All the subjects are going to see all the lists. Determine how many subjects the researcher would need for his study if he wants to run one subject for every possible random order of the 6 different word lists. Show your map so it's clear where you got your answer. So how can you know how many possible random orders there are of 6 lists? Yes?
I'll try. I don't know, I'm not sure. But I did 6 times 5 times 4 times 3 times 2 times 1. So that's equivalent to 720.
720. What do you think? Is she right?
Yes.
Abby's right. 6 times 5 times 4 times 3 times 2 times 1. So if they want to run one subject for each possible random order of those 6 lists, they're going to need 720 subjects for their experiment. That's a lot of subjects. Do you want to run 720 subjects?
No.
That sounds like too many. So instead, let's not do a complete design using all those subjects, right? Because that's what a complete design is. A complete repeated measures design is one where we gather data for every possible random order. That sounds like a lot of work in this case. So let's do it incomplete instead. And an easy way to select which possible random orders we should use for our study is to generate a Latin square. Okay? So we can make a Latin square for 6 subjects. I can do this with 6 subjects. And I say, use the sequence BDECFA as the first row. And look, it's right there. So, what would the next row be? DECFAB. Yeah. And how did you get that? We just, look, it's research as interpretive dance. Okay, it works. During the test, you're just going to stand up and go, for this one, it's... And they'll say, I think you need to put that into words, actually. This is a critical thinking through writing class, not a critical thinking through dancing class. That's a different thing. We can talk about that. Sounds like it could be fun. We'll get some exercise for sure. Okay, so it would be, actually, let me see. Let me grab a pen. I can actually do this. Oh, it's technology. Okay, D, E, C, F, A, B. Okay, what's going to be this one?
E, C, F, A, B,
D.
D. Okay, and what's next?
C, F, A, B.
Okay, next.
F, A, B, D, E, C.
And?
A, B, D, E, C.
Okay, and what's the secret of the Latin square? What does it let us do? Why do we like this?
Everything in every spot.
Everything in every spot? Come on, we can rhyme that. This is Atlanta. We can rhyme anything in Atlanta. Everything in every spot. Every condition in every position. Rhyming helps. But everything in every spot works too. Takes up less space on your note card. But every condition in every position might be easier to remember because it rhymes. I told you one time I had my research methods students, it was an honors research methods class, and they did their final as a rap. That was pretty awesome. That's where I got my nickname, Dr. D. Crunk. They made me a t-shirt and everything with like big dollar signs and glitter. It was really cool. It was the most fun. The rap final was great. But how long ago was that? I have the recording on VHS tape. Oh my God.
Wow.
I know. I scared somebody. I was talking to one of my colleagues and she said, so when did you start at Georgia State? I said 1999. And I was like, yeah, I probably have students who, pretty soon I'm going to have students who were born the year I started. Yeah. She's like, you can't be that old. You look too young. I said, oh, thank you so much. Thank you. I can go with that. Okay. It's just good, clean living. Okay. A researcher has a sample of 30 rats that are all cloned from the same source. The 30 rats are genetically identical and have been raised in exactly the same environment since birth. Okay? We good with that picture so far? Okay, 30 rats. The researcher conducts an experiment. Randomly assigning 10 of the clones to treatment A, 10 to treatment B, and the other 10 to treatment C. Okay? This is our situation. 30 rats. They're all clones, so they're all genetically identical, and they've all been raised in exactly the same environment. Okay, this is actually not totally physically possible, but we're imagining. I know, it's so handy. But the purpose of having this marvelously artificial situation is so that I can ask you the following two questions. Explain why the clone experiment is better than a typical between subject study using 30 regular rats. So just regular old rats that aren't genetically identical and haven't all been raised in exactly the same environment. Okay? Who are randomly assigned to 3 treatments. In other words, explain how the clone experiment addresses the primary challenge of creating an effective between subject study. Application. All right, so let's think about a couple things. First of all, how is this better than just using 30 regular non-clone rats? Why would it be better to use clones that have all been raised in the same environment? What's good about that?
Because they're essentially all the same. So if they're all genetically the same, it's like nurture and nature. Like
Everything nurture and everything nature is the same. So what's gone? What have we gotten rid of? Potential extraneous variables, particularly those that relate to? What's the magic word? 2 words. We're going to play 35-30 charades. 2 words. First word begins with I, second word begins with D. It's the biggest problem with between subject studies. Our biggest concern.
Internal validity.
Nope, that would be I and V, but good guess. What's the biggest challenge of creating a between subject study? There's a PowerPoint that actually says this right across the top. The biggest challenge of creating a between subject study is
Creating groups that are similar.
creating groups that are similar enough to compare in a meaningful way. And why is that a challenge? Why is it hard? Individual differences. That's right. ID. Individual differences. Okay, so our biggest concern is individual differences, right? Because individual differences bring with them a host of potential extraneous variables. Okay? Extraneous variables are a problem. We don't want them. We need our groups to be as similar as possible. And if I've got just 30 old regular rats, well, they could be different in their age, in their sex, in their weight, in their temperament, in their personal experience, where they went to high school, whatever, you know, they could vary. And but if I've got 30 clone rats, they are genetically identical, they've grown up in exactly the same environment, I have effectively eliminated individual differences, right? Or made them so minor that they're not going to threaten my study at all. Does that make sense?
Yes.
But until we can use clones for research, you are never going to be faced with that case, right? We don't, and plus, would you really want to use human clones for research to learn about humans? Why not? Because it's not representative, right? If we used human clones, the thing is that even though individual differences really challenge us when it comes to doing a between-subject study, it's our individual differences that make us interesting, right? So even though as researchers we want to try to create groups that are as similar as possible, we also have to keep in mind that the diversity of our sample is really important so that it will generalize to more real people. So, why is it better than a traditional between-subject study? Somebody tell me now, in their own words. Why is it better? How does it address the challenge? It can't be Javier. He's right there. No, stand down. Yes.
Cancels out individual differences so that it's a more even playing field between your subjects.
So, the fact that the subjects are clones effectively removes all individual differences, meaning that our groups are automatically as similar as they can possibly be. So we've addressed the challenge of between subjects designs by creating groups that are clearly similar enough to compare. Make sense? Okay. Now, making things a little trickier. Explain why this experiment is better than a traditional within-subject study using just 10 regular rats that are each tested in each of the 3 treatments. In other words, explain how the clone experiment eliminates the primary challenge of creating an effective within-subject study. So, one of the reasons we like within-subjects designs is because we have the same subjects in every condition, right? So now individual differences don't matter because whatever individual differences our subjects have, they have them in condition A, and condition B, and condition C, so it doesn't really matter, right? Because they're experiencing all of the conditions. But how does our clone experiment address the biggest challenge of a within subjects design? Because it's not individual differences. What's the biggest challenge of a within subjects design? Sequence effects, right? The order in which the conditions are presented to the subjects. Because you want to make sure that experiencing condition A doesn't change how they respond to condition B in some way that makes it hard for you to tell the effect of condition A and the effect of condition B. Or that B doesn't affect C in some way, right? Sequence effects are our biggest worry with within subjects design. How does our clone experiment address this? Okay, I'm going to read the description of the experiment to you again. A researcher has a sample of 30 rats that are all cloned from the same source. The 30 rats are genetically identical and have been raised in exactly the same environment since birth. The researcher conducts an experiment randomly assigning 10 of the clones to treatment A, 10 of the clones to treatment B, and the other 10 to treatment C. So how does that address the problem of sequence effects? Ooh, I can tell this one needs to go on the test. Yes?
Wouldn't it be that a certain number of the clones are being like, are getting a certain treatment, so you're not having to worry about the order in which they're receiving the treatment because they're all the same and experiencing the different.
I think you're on the right track. So the issue here is that in order to have sequence effects, each clone has to experience every treatment, right, in some order. In the clone experiment, are they experiencing more than one treatment? No. Each one is experiencing only one treatment. So the clone experiment is a between subjects design. Each subject, each rat is experiencing only one treatment. As a result, there's no opportunity for sequence effects to emerge because they're not experiencing multiple treatments in any particular order. Each rat gets only one treatment. So there are no sequence effects. So we could, if we could run all of our experiments on clones, we wouldn't have to worry about between subject design issues, we wouldn't have to worry about within subjects design issues. The problem is that the only population those data would be any good for are clones. That's not going to help us. So we have to deal with the issues of diversity, the issues of representativeness, the issues of having a varied sample, however they present themselves. And sometimes, because we need data about different people because people are different. That's why we worry about this stuff. That's why we want to train you guys to know how to design effective studies or to recognize well-designed studies. Whether you choose to go on and do research yourself or not, you want to recognize good research when you see it and recognize junk science when you see it. Because you don't want to make important decisions in your life based on bad data. Does that make sense? That's my goal. I want to make sure that you can recognize good science when you see it and know when to pay attention to it and when to go, excuse me, what was your control group? Excuse me, did you randomly assign subjects to conditions? I don't think so. I think your data's biased. I'm going to go check some real science. Totally, be a science snob. That would be really very happy. Okay. All right, this may be the very last one we get to. We may not even get all the way through this one. We might have to start here next time. All right. A researcher is investigating the relative effectiveness of two different weight loss programs. We'll just call them Program A and Program B. Participants will be assigned to one of these two groups or to a wait list control group, which we'll just call the control. Here are the weights in pounds for the 18 participants who have volunteered to be in the study. Participants are listed in the order they arrived at the laboratory. So we don't know anything about these people except this is the order that they showed up at the lab and this is what they weigh at the beginning of the study. Okay? So, here's your first task. Your first task is to randomly assign participants to the three groups using block randomization. Put the blocks and the participants' weights in the appropriate boxes below. Then down here in this box, the large box, you're supposed to explain what you did in words. Okay? Because we're going to practice articulating what we're doing. This is important for writing things like the procedure section of a research paper where you can actually explain what you did so somebody else can replicate what you did to see if your findings match theirs. So we're going to do block randomization. I've got a bunch of weights. I know what time the people came into the lab in order. So what do I need to do? Help me out here. I'm going to pull up the screen here. Let's move this up. Let's set it up so that the bar doesn't actually go through. What should I put in these boxes? It says I need to put the blocks and the weights in the boxes. Well, there's a hint. One of the things says block. So we might start there. Okay? So what information goes under block?
Probably the participants and their weight. What I was done on as far as the block is put 3 people in the first block. Well, I put the first 3 people that came in the first block with their weight.
Okay, that's fine, but what block are we using? What's a block? Kind of treatment. So what's a block for this study? Give me an example of a block.
Could it be the, like the top, ribbon with the most weight?
Nope, that's not a block. Nope, you're thinking, but you're a couple steps ahead. What's a block?
A weight loss program. Or in this situation, what would it be?
Which condition, right? We need some conditions, but like what?
A, B, C.
Where does-
Program A, program B, and control.
So you want A, B, C, like that?
No. A,
No?
B, C in the first.
Oh, here we want me to put A, B, C. So diet A first, diet B second, control group.
Yes.
That's a block, right?
Yes.
A block is a random order of all the conditions. So what might go here?
B, C, A.
BCA is a perfectly good one. What goes here? CAB, also another perfectly good block. What goes here? BAC, sure. What about here?
CBA.
CBA, okay. What about here? ACB. So how do we figure out blocks? Blocks are just random orders of the conditions. And each condition is represented only one time. That's a block. Okay. And does it have to start with ABC? Could these be in a different order on your worksheet? Absolutely. It makes no difference as long as you use all 6 blocks. You can use them in any order. Depending on the order you use them in, you're going to get different answers. Yeah.
When is it helpful to, it's like we almost did it, but to reverse it, but to mirror it? When
What do you
you're doing the blocks and then you